Hello and welcome to this live stream event where we present you our new wireless emergency system. My name is Klaus Mohr and it's a great pleasure for me to guide you through. Before we start with the event, I need to do a bit of housekeeping. So everyone out there is muted, so we can't hear and we can't see you. But we still would like to get your questions. So please use the question function within the tool or use the chat to drop your questions. We try in the session to answer as most as we can, but if not possible, we will come back to you after the event. Unfortunately, as we're still in this very special situation, some of the speakers are pre-recorded. The whole webinar will also be recorded and will be available for you later on so that you can use it by yourself or share it with your colleague. So what are we going to show you today? So we are starting with a welcome. So we have some words from Hugo Rohner, our CEO, followed by Timo Pakkala, the founder of Casambi. My colleagues Manuel Stanzl and Elias Kernbichler will then give the introduction to the wireless emergency system. We then have live connected Simon Blazey from the UK, and he will talk already about reference projects. Then I will have the pleasure to have again back Manuel and Elias talking about the system and showing what it is all about and how it looks like. After that block, we will already start with a Q&A session, so please be ready and send us your questions. After that, we have Stephen Jackson from Casambi. He will talk about planning and requirements for wireless emergency lighting. And after that, as well, very important is, of course, the Luminaire design. So we have then Harald Müller, our application engineer, and he will talk about Luminaire design in, so that you have a good connected Luminaire. Then we will have the second part of the Q&A. And finally, round about 4:30, we will close that event. But now I would like to welcome on stage our CEO, Hugo Rohner.
Hello, everybody. It's an enormous pleasure to be with you today. Thanks very much to join. It is a milestone today, what we present, the first wireless emergency system. It is a wonderful partnership between Tridonic and Casambi that made this possible. Tridonic, with its long-lasting experiences in components for the lighting industry, and Casambi with its superior knowledge on wireless and mesh networks. Together, we have made it, and finally, you can have also a wireless emergency system so that all lights can be wireless, which is something absolutely great, and we have the enormous pleasure today to show it to you in this webinar today. Thanks very much again to Casambi for this great partnership. We as Tridonic, we are proud to be able to do that. We always want to be easy to work with, and for the wireless solution, Casambi certainly helps and enables that, but also for everything else. We hope you find it useful, this webinar, and you can learn a lot. I think we have a great solution, not just for refurbishment projects, but also for everything else that you want to have connected wireless. In that sense, I wish you a great afternoon, and I hope you really enjoyed. Please use the time to ask all the questions you like to ask. This is the moment, and we are proud to have you with us here this afternoon. Thanks very much.
Thank you very much, Hugo. And now we have as well some words from Timo Pakkala, founder of Casambi. Terve, Timo.
Good afternoon. As most of you know, we've had a long and strong partnership with Tridonic for several years. We've been working together on a basic dim wireless solution and products for quite some time. And it's been a great collaboration. But last year we took our relationship to a next level. We worked together on our new wireless DALI gateway and made sure that it absolutely works together with the SceneCom solution from Tridonic. And of course, today we are introducing a new solution, wireless emergency solution. And this is a great example of what we can do together when we bring to the table our respective strengths. Tridonic is of course a pioneer in DALI systems, and they have a long history with the emergency solutions as well. And of course, Casambi is early adopter of BLE technologies, wireless technologies, and of course we were the first company to introduce true wireless mesh to the lighting industry. But it is important that this does not only strengthen Casambi and Tridonic, this strengthens the whole ecosystem. By having a more complete solution, this makes the whole ecosystem more attractive for specification, and this creates more demand, and again this brings new players to the ecosystem. So you get the picture. This really is the beauty of the ecosystem. It is truly a self-reinforcing system. So this has been a great collaboration with Tridonic, and we expect that the results will speak for themselves. Thank you.
So we have, as I said in the beginning, we have pre-recorded some of the videos. Some of the speakers are recorded, and we will just bring them in a second. So please stay tuned. Be ready for the nice introduction. Then, as I said before, Manuel, Stanzl, and Elias Kernbichler, product managers here from Tridonic. So you get now the information out of first hand from the colleagues. I just see in the back that the video will come in a second. So
thank you for tuning in today. We would like to present to you the new Tridonic wireless emergency system. Therefore, I have my colleague with me, Elias Kernbichler, who is the product manager for emergency systems at Tridonic.
Yeah, thank you. And right next to me is my colleague Manuel Stanzl, who is the product manager for wireless lighting.
Very good. So we would like to start with the basics of the emergency lighting in general. And let's start with a simple question. Where can I find emergency lighting?
Yeah, so emergency lighting can basically be found everywhere. Emergency lighting is mandatory in most of the installations, and it is a very important aspect in every building. So it's required by law, and if you go, for example, in an office building, in any publicly accessible building, any warehouse, these are just examples of where you can find emergency lighting. Of course, an important point with emergency lighting is that you need to test it regularly and that you need to have system checks in place.
So basically, you can find those emergency lights everywhere. And my question is, how are they carried out?
Yeah, so it's a good question, because even in this day and age, emergency lighting is mostly done with what we call manual testing. Manual testing means you need to go on site to the installation, you need to switch off the main supply, and then you check each luminaire individually for its functionality. And there are, of course, more sophisticated solutions available, but those are very rarely used.
Okay, so emergency lighting, it seems obvious that the safety has the highest priority. And how do you ensure that the emergency lighting system offers the safety?
It is ensured and it is enforced by law. There are regulations in place that require you to test your emergency lighting. Your emergency lighting needs to do a functional test at least once a month, and it needs to do a duration test over the whole duration of normally either 1 or 3 hours once a year. What you also have in the installation is that you need to replace your batteries. You probably know it from your phone, from your notebook. Batteries tend to have a decrease in capacity over time. So after some time you need to replace them to ensure your emergency lighting still has the functionality as required.
Sounds like there's going a lot of work in these maintaining of these emergency solutions.
Yeah, indeed. It is a labor and time-intensive job to do the testing and all of the reporting if you do it manually. As said, at least once a month for function and at least once a year for the duration. Also, if you realize during one of these tests that an emergency luminaire has failed, then mostly 2 site visits are necessary. First of all, you go there for the check. You realize an emergency luminaire is not working anymore. And then you go there a second time for the replacement, as the spare parts are normally not carried in your pocket in the day-to-day life. Most of the times, these are batteries that need to be replaced, as explained. But there is an alternative to that, to the 2 site visits. I think this alternative is even worse because it means that as a precaution, after 4 years, even if it is not necessary at that point in time, you will replace your battery. This is, of course, a waste of money and resources, and it is a very bad habit for the environment, as a lot of battery waste is created in that process. Mm-hmm. So for me, that begs the question now, Manuel, you as our product manager for wireless lighting, how can you help me to make my emergency lighting more efficient?
Yeah, and that's why we are here. You heard with the manual testing, there's a lot of work going on, a lot of inefficient processes. So we are here to introduce to you the wireless emergency lighting. If you go to the next slide, you'll see that we use for that our basic dim wireless system in general. The basic dim wireless system is our network for Casambi-enabled devices. And we have chosen the basic dim wireless network because it's based on a Bluetooth mesh network. It's fail-safe. So even if one luminaire is going or has a malfunction, it connects automatically to the next one. And this is very crucial for such an important topic as emergency lighting is. We have a lot of luminaire manufacturers watching this session. So for me also, it would be interesting to see how it does look inside of a luminaire.
Yeah, so inside the luminaire, it is pretty simple because the only thing you need to introduce to your luminaire is a small wireless module. So if we look, for example, at dedicated emergency lighting, here with the example of the EM ready to apply, then we already have the electronics inside, we have the battery inside that is used for to gain the energy in emergency mode. We have the LED as a light source, and now we have simply connected inside the luminaire via DALI the basic dim wireless active module, which already has an integrated power supply, so there is no need for any additional DALI powering. But it is also possible to integrate emergency lighting into a standard light fitting. So when looking at a standard light fitting, you have your LED driver and you have your LED module. This is the most simple configuration that it can occur. And to that, you add your emergency driver, again with the battery that gives the energy in emergency mode. Now again, you connect the basic dim wireless active module with the integrated power supply, and you can connect it to the emergency driver. But would it also be possible to have the basic dim wireless module connected to the LED driver additionally if I want to control my lighting?
Yeah, sure. If we look at the overview again, we have covered the wireless system. So I've explained in detail how the wireless emergency luminaire could look like. But as a matter of fact, the mesh network could also have the normal functional lighting, sensors, push button inside of it. With the DALI gateway, this passive module, with the DALI gateway profile on it. We have a translator from the Bluetooth mesh Casambi network to the DALI short addresses. So it really translates those Bluetooth addresses to DALI short addresses. And a nice configuration possibility is to really pick and choose which addresses should be translated. So in an example, you could use your normal lighting, your scenes, your sensors in the basic dim wireless system, still in the basic dim wireless system, and only pick and choose the emergency wireless luminaires to be translated to the DALI line. And this DALI line is connected to a SceneCom controller. And why we use the SceneCom controller is that with the SceneCom controller, we have a proven system, it's reliable, and the most important part is we have this nice functionality that you can carry out automatic emergency functional tests and the reporting of the emergency lighting.
So if I understand it correctly, SceneCom is then acting as, so to say, the brain of the system.
Correct.
But how do I now access the data on the SceneCom? How do I do all this functional testing and the reporting?
So the SceneCom controller has an Ethernet connector. And with this Ethernet connector, you can log in via any web browser and access the data. So you can access the test report, you can access the test book, you can even download it.
It sounds pretty nice. So if I have the SceneCom and I have my 3 DALI lines connected to it, then I can install up to 192 luminaires, 3 times the 64 of the DALI network. But now, what if I want, if I have a bigger building, what if I have a larger installation and I want to connect more than one SceneCom? Let's say I have 5 or 10.
Yeah, for that we have also a solution. It's called EM-Link. That's a program installed on a computer connected to that network, to that Ethernet network. And with that EM-Link software, you can log into multiple SceneCom controllers and you can download those reports just all at once. So it makes your life pretty easy with a large installation. And you can really link up to 200 devices with that. And of course, with that EM-Link program, you have also the possibility to download it and have it as PDF or XML file to have it accessible physically if necessary.
That really sounds like a neat solution where all the pieces fit together like a jigsaw. But for me, the question still is present. Why shouldn't I go with the existing systems as I'm used to, but rather go for the wireless emergency lighting?
Yeah, with our wireless solution, you combine the benefits of both worlds. You have this nice DALI controller with the automatic reporting functionality, the automatic testing functionality. You have a built-in clock, so you can have scheduling as well. So automatically, just not having to care about anything. And additionally, connecting to a wireless system, which is reliable, which is fail-safe, like our basic dim wireless system, you connect those both worlds. You have simple planning, you have simple installation, you have remote maintenance, so you don't have to be on site. You can make it remotely accessible from all over the world, and you can access those data live.
Yeah, that really sounds like it saves a lot of the time and the labor that is going into the maintenance of an emergency system. So we have the SceneCom and the basic dim wireless, bring that together, and they are both very well established in the market. And yeah, that's really important for me, because emergency lighting, as we said, it is a safety critical topic, and I need to know what is going on in the installation. I want to know what happens there. And with this short introduction, I want to thank you all for your attention to the Tridonic wireless emergency system.
And I hope you have fun with the rest of the event.
Thank you very much, Manuel and Elias, for that introduction. We will see you both in a minute. So now I have the great pleasure to be connected live with Simon Blazey from Tridonic in the UK. Hi, Simon. How are you?
Hi, Klaus. Hiya. Good to see you. I'm just going to share
Good to
my
see you.
screen with you.
Thank you much for being with us. It's great to have you here, and it's especially very great that you can already talk about reference projects for our new solution. So, Simon, then I would say the stage is yours.
Yeah, thank you, Klaus. Thank you. Good afternoon, everyone. My name is Simon Blazey, and I head up our solutions team here in the UK. What is going to be clear for over the afternoon is that the demand and the opportunity for our wireless emergency lighting solution is going to be clearly evident, has been around for some time now. And here in the UK, we'd like to share with you some of the different reference projects that we've managed to create. They are at different various stages, but we also want to give you some of the reasons why the different clients I'm going to show you have gone and why they see value in that particular solution. The past few years has been challenging for us here in the UK for, well, pretty two big reasons why. That lack of investment, as we slowly we recover from this situation and the lack of investment will mean that the focus on retrofit projects will come much to the fore. And it's a couple of these type of retrofit projects I would like to start with first. Back in October last year, we worked with Casambi directly on getting wireless technology specified into two particular retrofit projects. The first one I want to show you is a project called Space House, or the address is in Kemble Street, London. Some of you might know the building, for those guys who know London very well. It was formerly occupied by the Civil Aviation Authority. It's in Kingsway in Holborn. The building is literally cut down the middle in terms of the design that Atelier 10 have specified us on. You've got two zones either side on each floor. A SceneCom controller, as the guys previously have showed you, sits in that zone, connected to a Bluetooth dialer gateway, and then connected to the emergency wire fittings. All in all, and as the guy shared with you earlier, you can do multiple controllers, and this has got in excess of 80 controllers managing 2,500 emergency fittings. And this is a job that's still in that post-design phase, in that tendering phase right now, and will be deployed throughout the latter part of this year. What's really smart, I think, about this particular project and the strength of the ecosystem that we've created between Casambi, ourselves, and others, and I'll introduce you to those in a while, is a real strength. What we did was that Casambi got themselves specified with their wireless technology. They assisted in getting ourselves specified for the wireless emergency. And what the client saw, what the consultant saw, was that the actual mesh, the wireless mesh, was stronger for having the emergency lighting within it. It was stronger because of the maturity of the Casambi mesh, and then bringing that into the Casambi mesh made the emergency lighting solution stronger with it. And the final partner that we're working with is Holders Technology, who are delivering the whole of this project, both from the Casambi side and the Tridonic side. So it's a really great example of an ecosystem of partners working together. The second project is with a well-known consultant in London for a job called 80 Charlotte Street. On this particular project, Casambi and Holders have managed to get themselves specified for the general lighting, and Tridonic have been specified now for the emergency lighting, and for the same reasons that I've just given you previously on Space House. Clearly, the mesh is stronger for having the emergency lighting in it, and that was also seen by Arabs. Now, last year, we spent a hell of a lot of time here in Tridonic working with one particular type of client. the asset manager, looking at around the ideas of how they could serve their clients better than they do right now. You know, we've all been attending webinars like this and Teams calls for feels like a long time, but it's just over a year. But whilst we've been doing that, many buildings have been empty. And these asset managers found themselves having to drive to empty buildings, man in a van, whether to test emergency lighting or flush taps every 6 days to avoid Legionella. And these asset managers realized, and when I talk about an asset manager, I'm talking about your corporate asset manager or your FM type contractor or your estates manager for a large campus, whether it be a hospital or a university. And this particular corporate asset manager shared with us, and there was one particular senior individual, senior executive at this asset manager in a meeting shared with his counterparts. He declared that their tech stack was too low. What he really meant was that they were too labor heavy in the way that they support and manage the buildings of their clients. So they realized that the way ahead is to use technology in a far more better way. And that's why they approached us. They want to serve their clients in a different way and use the data that we can provide, whether it's actually our LUM data out of our drivers or what the guys have shared with you, is about automating the emergency testing. That can be done remotely and then pull off the reports remotely would be a great advantageous value proposition that they could give to their clients. What it did do for us, though, was actually create a value proposition, a market approach that we built all of these discussions around, which is a proactive approach to lighting asset management that we call our building asset 360 market approach. Now, within that market approach is a number of different elements, whether it be using a LUM data out of our DALI controllers, the ability to share that data in an open way, whether it be via an API or you'll see in a moment through other interfaces like EM-Link and BACnet. But actually what is at the core of our Building Asset 360 market approach is the elements around our wireless emergency system, whether it be the ability to automate the testing, but also then not only to automate the testing, the ability to access those reports in many, many different ways, whether it be in the building itself, or on the cloud or in some other form. It's not dependent upon just one aspect of that, whether it be cloud or in the building. What these particular asset managers wanted from us was to be able to be different in the way that they reacted to a light failure in their maintenance regimes. And more importantly, to be able to test their lighting automatically, but also deploy it in a wireless way that is great from a retrofit perspective. But they also wanted to be able to react differently to when the test has actually happened. And actually, rather than attend site to do the test and have to come back later to actually repair the test, if there's anything has failed, but actually to be able to do it in a one-stop shop situation based on the information that they're being able to get out of the system. What they really wanted was actually to find a balance between the way they reacted in a reactive maintenance way, or that probably knee-jerk reaction to do some preventative maintenance to actually repair or replace a whole floor, and what we call intelligent maintenance. They want to use some of our LUM data that we have in our drivers to achieve that and to enable them to start to create their own planned maintenance regimes. But they more importantly wanted to add our emergency lighting testing, the way that we can automate it now, which ultimately came to our Building Asset 360 model approach. To give you an example of what we're actually doing with them, at the moment we're deploying through a pilot project a number of buildings connected with SceneCom controllers in those buildings via the EM-Link software that the guys referred to, and then their third-party platform that they're developing. They can pull the reports out via an XML software platform to actually report straight onto their own system. This will mean then they can offer their clients in the future a different way that they can serve their clients and take off the man in the van only for when they actually really need them to actually attend site. We have other clients We want a variation of this over multiple buildings, you know, small retailers or schools or something like that, where actually they can simply have an email that can be actually set up to be scheduled automatically after the emergency test had taken place, to be sent to the responsible person, and he will get an email with a PDF inside his email that he can pull off, and that can be start to build up his logbook. The last example I want to give you is something where a client we're really excited to be working with. SSE Enterprise, the BMS, the energy solution within SSE themselves. We've been working with them for a year now to open up the opportunity to work with this system integrator. We have a lighting solution working with Casambi and our emergency lighting solution that we can join with what SSE already do and offer a combined solution for their clients. We've started by deploying this in their office in Egham. We've actually replaced their lighting at the same time. And in essence, what we're really doing is putting our basic dim wireless lighting system coupled with our new emergency lighting system. All of this has been deployed in the last month, and that will be now connected to their BMS system. Now, the options of how we can connect to that BMS system is probably the last interface I want to show you. And so in reality, we're connecting their lighting system, their own lighting system, straight through the SceneCom controller, which has got its own backnet ability to interface into BMS systems. And the individual alarms, the individual luminaires and data around those luminaires, and the individual test report of those luminaires will now be extracted into their BMS system. And now we'll be developing a strategy with SSE that we can now deploy that to some of their clients in the future. So hopefully, ladies and gentlemen, I've showed you now a few different types of reference projects that give you an insight into the opportunity that's available around our wireless lighting emergency system. Thank you very much. Back to you, Klaus.
Now I will welcome back Manuel and Elias. So they will now give you an insight. What is the system about? How does it look like? From what components do we talk about? So Manuel and Simon will now talk, Manuel and Elias, of course, will now talk about the demo system setup.
Welcome to this session where we're going to talk about the system setup.
So we have a live demo system here in front of us of the wireless emergency system. And Manuel, can you please talk us through the individual components that we see here in front of us?
Sure, no problem. As you can see on the slide, we have different kind of devices, which we all have here on the desks. First of all, the wireless emergency luminaires, powered by mains. And on my right, you see the SceneCom controller and a router. The Ethernet connection of the SceneCom is connected to this router to enable a Wi-Fi connection. This is very beneficial for us because we can use a tablet to configure both systems. Mm-hmm. Yeah, but talking about the wireless luminaires, Elias, could you quickly talk us through how it looks inside of such a luminaire?
Yeah, of course. So in front of us, we have the EM ready to apply. And the EM ready to apply already consists of an emergency driver, of a battery, and of an LED module for the light. And what we add to that is a basic dim wireless active module. It has an integrated DALI power supply, and it allows you to simply use one single device that powers via DALI the luminaire and enables the wireless connection. So this is the most simple luminaire setup you can have, but of course there are other options, like for example if you want to integrate emergency lighting into a standard light fitting, then you can also do that by adding the basic dim wireless module. You again have your luminaire setup now with a driver, with an LED module, and you have the emergency driver and battery that you add additionally. of course, to establish the wireless connection, here again, the basic DIMM wireless active module with the integrated DALI power supply to really have only one single module that allows you the connection via DALI to the Luminaire and also on the wireless side. And so now that we know all of the components that we have here in front of us, let's move on to the live setup.
Now we get to the exciting stuff, to set all of this system up and see how they are working together. So Elias, thank you for explaining how the inside of these emergency luminaire look like. And I think we should start with setting up the basic DIMM wireless network. And for that, I'll need my tablet. And I'm gonna start with opening the Bluetooth for Remote BT app, which is the app you will need to configure the basic DIMM wireless system. I already see that 3 new devices pop up.
So we see 3 devices here, but only have 2 luminaires in front of us.
Yeah.
What is the 3rd device all about?
Yeah, that's the DALI gateway. This is the enabler, the translator from the wireless world, from the basic DIMM wireless world to the cabled DALI world.
Okay, so, and in the app, how do we now move forward if we see all of our devices?
Yeah, so simply we would like to create a new network. We simply touch or we simply switch all the luminaires to a new network and say we would like to create a network. Now we have the possibility to choose between classic and evolution firmware, but for this setup with the DALI gateway, we need to choose the evolution firmware.
So what does that mean if I now have an emergency luminaire with a classic firmware installed?
That's no problem. When you're at this point, you can choose, simply click on the luminaire and update the luminaire very easily. So I'm gonna choose evolution, like I said before. I have to give the network a name. Let's say we are in an office. The network has been made. So it needs a few seconds only, and then you're ready to move forward.
Okay, but again, so here I see my 2 luminaires that I have. You said we also have the gateway now in the network.
Yeah.
Where do I set up the gateway? What do I need to do there?
Of course, the gateway is not a luminaire. That's why you don't see it right away in the overview. But if you go to the More tab on the bottom right, you have the possibility to choose gateways. And there you see right away that I have now the gateway implemented already. And inside of this configuration tab, you have a wide variety of different settings. But in most cases, this configuration is already perfect for a standard installation. And in our case, we also leave it as it is, because we have only emergency luminaires. But in the case, if you have also functional lighting, sensors, and push button already in an installed network, basic DIMM wireless network, you probably want to have only the emergency luminaires transferred to the DALI controller. That's why you have here the possibility to choose a control scope. So you can really pick and choose luminaires who do you want to control with the DALI controller, with the SceneCom controller.
Okay, so, but in our case, what we have here in front of us is a pure emergency wireless system. So that means, are we done?
Yeah.
How do we move forward?
Basically, on the basic DIMM wireless side, that's it. So, yeah, only those few clicks are necessary to establish a system, a wireless emergency system on the basic DIMM wireless side to be connected to a SceneCom controller. And what we're now gonna do is to configure the SceneCom controller. And like I told you before, we have this nice little router connected to the Ethernet cable from the SceneCom controller. And that enables to have the Ethernet connection on the Wi-Fi, and I can access the scene controller just by using the browser. And that's what I'm going to do.
So how do I know how to connect to the SceneCom? So what would I type in my browser?
So you just need to know the IP address of the SceneCom controller. And in case you forgot it, you have two options. You can look inside of the manual, or if you have the SceneCom controller in front of you, it's 10.10.42.5.4. You type it in your web browser. Of course, you have to be sure that you have established the Wi-Fi connection to the SceneCom controller and the router, and that's it. So now I have this overview, the dashboard, and of course I want to address those devices on the wireless side.
Yeah, I want to have my luminaires inside of the system,
sure.
yeah.
It is no different between luminaires on the wired side and the wireless side. So the commissioning is the same. And what I'm going to use is the addressing wizard. It's a simplified way to make sure to address all of the luminaires which are connected to the DALI line.
Okay, so if we now go through the addressing wizard, what exactly do I need to do here? We have the wireless now. How do I set up the controller with the luminaires?
As you can see in the addressing wizard, it really says you what you have to do. And now I have to add a room, which I call office. And in the next step, it's mandatory to enter a name for a group, so grouping. And in our case, we have only a wireless emergency luminaire, so emergency luminaires. I will name it emergency luminaires.
Yeah, that makes sense.
Save. Now, with this touch on the check button, it's searching for unaddressed luminaires.
Okay, so that means now, same as if I would have connected wired luminaires, it does exactly the same here for our wireless luminaires.
Yeah.
And we see also that blinking pattern of the LEDs changed. What does this indicate?
This indicates that the DALI controller is searching on its DALI lines. It has 3 DALI lines, and it searches for unaddressed luminaires. When we talk about the process now, it really goes through the DALI line, so disconnected line, and searches through this DALI gateway to see if there is any unaddressed luminaire.
So that means for my emergency wireless luminaires that I have now built up with the wireless node inside, they will be registered as luminaires already here in the SceneCom.
We should see 2 luminaires popping up. And this is exactly what is happening right here. We have now 2 luminaires.
Ah, yeah, I see that.
Yeah.
But I also noticed something here.
Yeah.
The indicator LED on this luminaire started to flash. So what information does that give me? Why did that start to flash?
Yeah, just imagine you have a big installation and you're walking around with your tablet, and now in the next step you should name the luminaires. So in case of something is happening, you right away know where this luminaire is located. But if you're walking around in the commissioning process, you want to know which luminaire is addressed right now. And the indicator light helps you with that.
Okay, so I would directly see which luminaire I'm working with now.
Correct. So what I'm going to do is I will give it a name for the first emergency light, like EM1. If I have to choose in which group it shall be, so emergency luminaire sounds right.
For us it's pretty easy.
Yeah, for us it's pretty easy. And the next luminaire, as you can see here, the next luminaire is...
Ah, yeah, the indication starts.
You right away see that now this luminaire is addressed, and we are working with this luminaire. Okay, in our example, only 1 luminaire is left, so it's pretty easy.
Yes. Is it mandatory to do the naming, or is it just something that helps you in the process of installing and
it's not mandatory. But just imagine a big installation. I would suggest to give it a thought about naming, because otherwise you're pretty lost afterwards.
Yeah. Makes it easy to indicate where it is afterwards, yeah?
Yeah, sure. So let's continue with the process. I've chosen the right group. Now the addressing wizard is going through input devices and other stuff, but this is not interesting for us because we have only those emergency luminaires in our case.
Okay, so the addressing is now done and our system is set up.
Basically, yes.
That means I would now be able to go to the emergency lighting functionality and check if it's working properly. So in an installation, I would normally not be connected to an emergency system with a tablet. I would like to access it with a PC, and as you've shown, we have a wireless router here. So for me, it should be also pretty easy to simply connect to the same wireless network, so to the same Wi-Fi network, and then access all of the emergency lighting functionality. If I now start to work with the Syncom controller, does that in any way interfere with what you're doing?
No, absolutely not. You can use your tablet in the same time as using your laptop or netbook with it. So that's absolutely no problem.
Okay, so that means I will now start to look into the emergency lighting functionality that we see here from the Syncom. And for that, I go to the menu and select emergency luminaires self-contained. Here we have a neat little dashboard that shows us, first of all, the total number of installed emergency luminaires, and we see how many of the luminaires are faulty. In our case, we have 2 luminaires installed and none of them have recorded a failure. We also see the operating mode in which they are at the moment, and both of them are in mains operation. Right next to it, you see when the last function and duration tests have been carried out, and you have the option to also start a function and duration test. Now, I will now start a function test. You will see that both luminaires will switch on. So, start it now. Both of the emergency luminaires now have switched on the lighting. And what they are doing is they are really switching into an emergency operation. That means for the few seconds that you've seen, those luminaires are powered by the battery that is built inside. This is done to check the basic functionality of the battery, of the electronics, and of the LED. So here, after this is done, they now have the result stored inside of the luminaire. And what the Syncom is doing is now he waits, because if anything would interfere with the testing of the luminaires, then the Syncom gives the luminaires still a little bit of time before it really grabs the information from the luminaire and stores it in the Syncom. With that, it ensures that no false negatives are reported. For us, that means round about 2 to 3 minutes it will now take, and then we will see the result of the function test on the dashboard here.
So this is the function test, but there's also the duration test. What's the difference?
The duration test, as the name suggests, it tests the duration of the emergency lighting. So the standard durations are either 1 or 3 hours, and it would really switch into emergency mode for this desired duration. It is done to check if in case of an emergency event, if in case of a mains failure, you really have the time to evacuate the building and still have the lighting provided. Also, what we see here is on the left-hand side that we could lock all the luminaires. The lock functionality, or also sometimes called rest mode, inhibit mode, is used if a building would be unoccupied. An example for that would be a vacation period of maybe 1 or 2 weeks where nobody is using the building. Quite often it would make sense to switch off the main supply for the whole building. So everything would be off. That means for the emergency lighting, as it thinks there is an emergency mode, it would switch on. And the lock functionality prohibits that. So you don't drain your batteries and still can do your energy savings.
Really nice. Oh, I see that the test is done. The result is complete.
Yeah, exactly. So you see now that the test is finished. We see our last function test we carried out, and we see the result on the right-hand side. What we can also do is we can have a look at the test book. So it is a requirement that you have all of your tests recorded and stored. And the SceneCom does that for you automatically. You can now have a look at the test book, and you see here the last test that was carried out, which was our manual test now, was a system-wide test, and we see that it was completed. Also, you have the option to export the test in either a PDF or an XML format.
Okay.
You can use the test then to store it locally on your PC.
You started the test, you started it by hand.
Yes.
But is there also a way to do it automatically?
Yeah, of course. So you can also do all of that automatically here in the SceneCom, and for that, to configure it, we go to the settings. In the settings, you have then the emergency lighting functions. The first thing we see are test groups. The test groups can be used to test different luminaires at different times. Then we have the switching mode to either switch it to maintained or non-maintained. We have signaling contacts, and then we have the function and duration test. The function test, it is already enabled, as we expect if you use a SceneCom, you will also use the automatic function tests, and you can set the day of the week in which it starts at a certain time. You could also view the results in the test book or start the function test now. We already did that, so there is no need. And we have the option to go to the duration test and do a quite similar thing there. You see, we have different test executions, and you set them to a calendar date. There is also the option, as said, to have a different test group that tests at a different time, and this is also pre-selected here. So all of this testing is now done, and we have all of it set up so that you really have an automatic test system now ready as it stands here.
Wow, sounds good. That's a real benefit compared to manual testing, I would say.
Yeah, it is. With that, I think we have shown how the system is set up, how you configure it, and then how you can interact with the emergency part. With that, thank you all for listening to us, and enjoy the rest of your day.
Yeah, also from my side, a big thank you.
So, and now welcome Elias and Manuel here live on stage. We have taken, due to the worldwide pandemic, we keep the distance of 2 meters, and we will also have live now connected Simon sitting in the UK, and now we're starting the Q&A session, and we have here in the back Andy, which will now bring us the first question. Andy, please.
Thanks a lot, Klaus, and thanks for all the questions coming in here online. I want to summarize the first few questions because all of them were going into the same direction when it comes to system size, systems limitation in amount of devices connected. And I wanted to ask you, Elias, if you could summarize that once again. how many devices can be connected to a CNCOM controller and how many of the wireless devices can then connect it to the wireless gateways.
So yeah, thank you, Andreas. Thanks for the thanks for you, Klaus, and the system itself can, so one CNCOM controller can control 3 DALI lines. That means if you have 3 DALI lines, those are 64 devices per DALI line. The same is true even if you're going into the wireless world. If you connect a wireless gateway to this DALI line, you can still connect your 64 luminaires to it. That gives you in total 192 luminaires per CNCOM controller.
Okay, very good. And it was during your presentation mentioned that you need a DALI driver and a DALI emergency gear per unit. So it's always a DALI device mandatory in the Luminaire.
Yeah, Andres, yes, it is true. You always need inside of the Luminaire a DALI device, and to the DALI device you connect either already a wireless node that has an integrated DALI power supply, or you can also use a DALI device with an integrated power supply that in turn powers the wireless node.
Thanks a lot. And there was one question coming in: when you have really a big network with hundreds of thousands of luminaires, is there an app available to really identify the luminaires locally in the buildings? I think, Manuel, that is something that goes in your direction.
Yeah. So you've seen our live demo setup, and where I have assigned only 2 luminaires. But just imagine you have thousands of luminaires in a building, and in the basic dim wireless app, if you want to commission the luminaires, so first of all, the luminaire which is next to you is higher in this rank because it has a better connection. So all the luminaires you are surrounded of, they are on top of this list. And secondly, you have the possibility to click on identify, and then the luminaire flashes. So you right away see which luminaire you are addressing now. And then you can give it a name. You can think about something useful that you can identify the luminaire right away when there's some issues, or you want to do something with the luminaire afterwards in the app.
Thanks a lot. And there was also a question when it comes to the DALI gateway you just mentioned. How is that device powered? I think that was not clearly shown on the slides before.
Yeah, okay, the DALI gateway. This is the gateway or the module which is connected to one of the DALI lines on the CNCOM or the CNCOM controller, so the DALI controller. And the DALI controller itself gives the power supply. So this module doesn't need a power supply. It is powered from the CNCOM controller, and therefore you can choose or you can take the passive module.
And inside the Luminaire, how does it look there when you put the basic dim wireless devices in the Luminaire?
Yeah, so in the Luminaire, this is something Elias has shown in our live setup and in our first presentation as well. So inside the Luminaire, you have the possibility to use an active module. Active module means that the module has an internal power supply. And this internal DALI power supply supplies the power to the DALI driver. But it can also happen that the DALI driver has a power supply, internal power supply. Then you need the passive module. So it differs which module you need depending on your setup or how it looks inside of the Luminaire. But if you want to have the overview on modules we have in our portfolio, I would recommend to go to our website where we have listed all of the 3 modules which are available. And you can really see on the configuration on the specs what modules you can use, what the power supply is, which is provided by the module, and all the data you will need for planning, or just have a look on the website, and you'll see what you need.
Okay, thanks a lot. And also several questions were coming in if it's possible to use emergency combined with a standard LED driver, so for functional and emergency lighting in one luminaire. Is this possible with a wireless module, with a wireless luminaire?
Elias, maybe you?
Yeah, so of course, there are not only standalone emergency luminaires, not only pure emergency luminaires, but also you can have combined emergency luminaires where you have two devices with, on the one hand side, your LED driver, and then you have your emergency driver right next to it. You can connect both of them to a single wireless node, and it will then also be shown in the BasicDim Wireless app as one single device. So yeah, it's possible to use also the functional lighting in combination with emergency lighting for this.
Okay, thanks a lot. And there were also some questions coming in, like when it comes to the emergency testing. What kind of tests are there supported from the system?
So the tests which are supported are also the ones that are required by standard, by law. So you have on the one hand side a functional test, and on the other hand side you have a duration test. The functional test, it really checks only the functionality of the luminaire. So that needs to be carried out a little bit depending on the region, but in general at least once a month. And it checks if the battery, the emergency driver, and the LED light source are still working correctly. And then on the other hand side, the duration test, which can also be automatically scheduled, as well as the functional test, needs to be done at least once a year. And this really checks for the whole emergency duration. So if you have, let's say, a 3-hour emergency luminaire, it will run for the full 3 hours in emergency mode to check if the battery still has sufficient energy to power the luminaire. All of these tests can, of course, be scheduled, so they will be carried out automatically. The results are then stored in the SceneCom, and you get an automatic test book created.
Okay, thanks. And as you mentioned before, there was a question already, don't know if that's now related to the projects or better fits inside here. It was about the UK projects that are already under installation. If there is an interrupt on the, let's say, Bluetooth communication, how is that the system behaving?
So for the BasicDim wireless system, which is our, say, Bluetooth system, we are using Casambi as a technology partner. And the Casambi network is a Bluetooth mesh network. And this Bluetooth mesh network is fail-safe, meaning that when one module doesn't work anymore, it automatically connects to the next module or any other module which is in its range. So it really enables you to have a fail-safe network communication, which is very crucial for an environment or application such as wireless emergency.
Okay, and one question for Simon out in the UK that is targeting one of your successful projects, Simon. In that project, is it possible there to use the Bluetooth devices separated from the emergency gears, from the emergency devices? When I understand the question, right?
Yeah. What is your understanding of that question, Andreas? I'm not too sure what the question is.
No, it was again, you have a bigger project there, and is there the functional and the emergency part in one big mesh network, or are the networks separated?
No, they are separated by the fact that the reporting aspect of the emergency goes through the SceneCom. But as a mesh themselves, working as a mesh, they actually exist within the same mesh.
Okay, so the emergency part is managed by SceneCom, but they share the same mesh devices.
That's exactly right, yeah.
Okay, thanks a lot for that feedback. And there was another question in regards to the used components coming in, and the question goes into the direction: are the devices used for emergency, are those dedicated emergency devices, or are it the standard normal basic DIMM wireless devices?
No, they are the same modules you would use also for normal luminaires. So these are the same modules, no dedicated modules for emergency.
Okay, and one very interesting question. Is it possible to create kind of a hybrid system? So meaning to mix a wired DALI devices and the wireless devices in a project, in a system?
Yeah, so very good question. Yeah, that there is the possibility to have at the same time a wired and a wireless part in one installation. If you, for example, would already have a wired installation and you want to expand it with a wireless network, this is of course possible with the DALI gateway. It then again acts as the DALI gateway, and the remaining DALI addresses on the DALI line can be used in the wireless network.
Okay, thanks a lot for the answers. And I would say we try to follow up on the questions then afterwards online, that you will get that also with the presentations and the recordings, because that was also requested now several times. And I would like to hand over back to Klaus.
Thank you much, Andy. Thank you much, guys, for being here on stage. Please don't run away.
Thank you, Klaus.
We need you later for the final Q&A session. Thank you very much. So, thanks. Yes, as Andy said, correct. So a lot of questions are coming in. Yes, the webinar is recorded, and you will get the recording afterwards. So automatically for everyone who has registered to this session here. So, and now we're jumping in to handing over to Stephen Jackson from Casambi, and he will now talking about planning and legal requirements for wireless emergency lighting. So, Stephen, please.
Thanks, Manuel and Elias for the demo. Hopefully you all found it quite interesting, informative, and obviously because the solution is very new, I'm sure there's things there that that will be quite interesting for everyone that's listening. So just to introduce myself again, my name's Stephen Jackson. I'm the UK business manager for Casambi, and I've had quite a long involvement in this process on the Casambi side with the introduction of the wireless emergency solution. And so in this session, I'm going to explain a bit more about the relevant regulations, and also in a bit more detail the solution from both Casambi and Tridonic in the emergency option or offering that we have now. But first, I want to just recap on what really at a deep level the Casambi solution offers in the marketplace to partners and to end clients in particular. And this slide is quite a good way for me to explain the functionality and some new things that have come in the recent months also from Casambi. So talking first of all about basic and as you would expect, normal lighting control solutions. On the top line, talking about groups and grouping and scenes. We also have a gallery solution in the application where you can present and control from lighting drawings or photographs of the space. We offer circadian rhythm in regards to colour temperature control automatically. And then sensors around light sensors and colour temperature control of fixtures as well. And then coloured luminaires, a variety of different solutions on coloured luminaires, joining animations, joining scenes for animations, movement sensors, and so on. And then at the end of the middle row, you'll see here the new introduction of emergency lighting, and the topic that we're all interested in today. In addition to that, we have a new cloud API solution that some partners have been taking on in quite an aggressive way, which is excellent for us. And one element that's important today in the topic of emergency lighting with Tridonic is this wireless DALI gateway, which is really central to the solution that that we can offer in combination with Tridonic. So this slide, as I said at the beginning, is quite a good reference slide for the functions that you can gain and achieve from the Casambi solution as it currently stands. And obviously the addition of the emergency solution is really exciting for us all to be part of. So now it's important, I think, at the beginning of my slides to just reflect on the standards in emergency lighting and say that the importance of following the standards, adhering to the standards, has been really central to the understanding between Casambi and Tridonic on how this solution is being brought to market. And obviously, as you can see here, the main two that are relevant to us would be the emergency lighting system, and also the testing of the system and testing of batteries and escape lights, etc. But there are a lot of other relevant standards and requirements that the overall system will achieve and comply with, more so on the controller side and on the emergency lighting side and the component side. Then when it comes to the controller, the SceneCom controller, then the market would expect that we together provide the relevant testing requirements and cover the relevant testing requirements, both with the logbook and the functions that are provided through the controller. So the logbook would need to contain the date of the commissioning and in the future any changes, the date of inspection and testing, and the various modes of operation on the devices. And then the testing regimes, the automatic tests, monthly recorded, and the duration tests, also the same. And in monthly tests, the auto test should be recorded, and any manual intervention should also be recorded as well, and the same with the yearly tests. Clearly, the yearly tests would require to be done at a low risk time, where there's less people in the building and there's enough time for the local batteries to recharge over the period that they would be able to recharge in. So there's low risk having anybody in the building at the time when the batteries are being recharged. So this element of the system would be managed and documented by the DALI controller, the SceneCom controller. And then moving on to the next slide, just referring to the different elements of the standards and how they reflect and refer to both the components and the building itself. And as you can see in the slide, the different types of luminaires have slightly different standards requirements. The gear, which is inside the fixtures, and also the building as well, the various building requirements and overall system requirements. So now looking at the planning side, and in planning there's a number of things that that should be considered. The first and foremost, the devices that are in the field, the luminaires, and as you can see on the left, each luminaire would require to have an active module, a DT1 enabled node per luminaire, per emergency fitting, and each of these devices would be in the Casambi mesh network and communicate with each other. In addition to that, on the right-hand side, you can see the CBU DCS device, the DALI bridge device, which is Casambi wireless to DALI in its functionality. And so from one controller, you could have up to 3 CBU DCSs, and those 3 CBU DCSs relate to 3 times 64 wireless emergency luminaires. So it's possible to have up to 192 in total connected back to the SceneCom controller at any one time. One mesh network could be used, being that 250 nodes can be in one Casambi mesh network. Therefore, there would be spare capacity for other Casambi nodes in the same network, as well as 192 emergency luminaires, or the 3 times 64 could be across 3 different mesh networks. And I'll come on to this, these points shortly in some other slides. So the topology of the system on the right-hand side would be the DALI controller. The DALI controller, SceneCom, is connected via DALI bus to each of the DCS modules, and then everything downstream of that is wireless communication to the fixtures and to the active Casambi modules that are connected to the fixtures or inside the fixtures. So everything in the network communicates wirelessly and communicates to and from the DALI controller. Then thinking about the current trend, or the trend that has been in the market for some years now, and being a cabled DALI solution, there are standards and requirements, as we mentioned before, on the Luminaire side, various BSEN and ISO standards that are required for fixtures. And then on the controller side, again, there are standards and norms that are required as well. And clearly in the middle, there are specifications and standards for the cable. So the DALI standard identifies a specification for DALI cabling. And what now we've introduced is something similar, only instead of there being standards and norms for cabling, there are lots of standards and norms for wireless technology, in this case Bluetooth. So you'll see on the slide here the compliance that's required in various different countries. For example, the radio equipment, the RED directive is something that we comply with, and various other standards in regards to wireless Bluetooth, including DALI DT1. So we feel that the importance that we can bring, and the security and the knowledge of the information passing that we can bring is very robust, and if not better than wired DALI, meaning that when you reflect on the fact that each node has its own information and it's not relying on a partner node to provide that information back to the DALI controller. It could be argued that it's a lot more robust than a wired system, meaning that the wire could be cut at any time and those fixtures downstream would not be able to communicate, whereas in the Casambi world, all the nodes are both master and slave. So it's important again to reflect that we've given a lot of consideration together with Tridonic and ourselves on making sure that the communication is compliant to the relevant standards, and that we can fulfill a very robust solution around emergency lighting and all the various compliances that are required. So looking into the solution in a bit more detail, as an overview, you can have this topology where you would have 3 separate Casambi mesh networks. In each network, you can have up to 64 emergency luminaires that are Casambi enabled, and you have one additional node, which is the DCS module in the same network. The DCS module doesn't appear as a DALI device, so you can use the maximum of 64 for 64 luminaires, and the communication back to the controller would be a DALI bus. We feel that in a lot of occasions, the DALI bus will be a very short piece of cable, maybe only centimetres long, which would mean that the DALI controllers are within the same location or even in the same enclosure as the DALI controller, as CENCOM. And so in this instance, this is a good example of where we see the solution happening quite a lot in this type of topology. In the next topology, we could have a single Casambi mesh network with up to 192 wireless emergency luminaires, and those emergency luminaires would be paired or put into the same group or scene as the DCS, the DALI controller, but all in the same network. And to explain the solution a bit more, looking at this third option, we can also have wireless Casambi luminaires in the same network as well. So in one single network, we can have up to 250 nodes, and to have 3 then DCS controllers, each controlling and communicating those emergency fittings that are in that particular scene or group. So this is quite an interesting topology because it means that we are maximising the opportunity of having one single mesh network with multiple groups or scenes, but also having manual control of the non-emergency luminaires in the same network from either Casambi app or from other remote devices. So we feel this is quite an interesting scenario to present and to discuss with. Then a bit deeper into the setup, we have this control scope. So when the DCS gateway, DALI gateway device is paired to the network, it can be seen in the application, and it can be defined in 2 different ways in relation to the emergency solution. If all the luminaires in the network are emergency only, then you choose all luminaires in the menu, in the gateway parameter menu. That means that all the emergency Casambi enabled devices that are connected and communicate back to the gateway are presented back to the DALI controller as emergency devices and nothing else. It's then possible in a mesh network where you have both standard luminaires and emergency luminaires to use the scene method, whereby you would select a scene that would be created, and in that scene would be all the emergency wireless DALI devices connected to the light fittings, the emergency light fittings, and they would then be communicated and controlled via one particular DALI gateway device. So both solutions can either mean that you have one single network and they would only have emergency inside, or you could have a single network with both standard luminaires and emergency luminaires. But the DALI controller would only recognise those emergency luminaires via the DALI gateway device based on the scene or the group that's been set up. And then my last closing slides are where I want to talk about the Casambi ecosystem architecture and why we impress strongly about standardization of hardware and the hardware environment, meaning the Nordic semiconductor device that we use. Then second of all, the single firmware implementation, where we manage the firmware ourselves to make sure that all ecosystem partners, in this case Tridonic, can have their devices communicating on the same firmware platform, and ensuring the interoperability of all the components from the emergency luminaire through to the DALI controller. And then very importantly, having the possibility to do debugging remotely. And as some of you may have had experience with Casambi before, there's a number of excellent solutions in the Casambi app whereby we can debug both as feedback to our support team and provide information on the setup of the networks and provide and request support on that side, but also fixing any bugs that may occur. And the way that's done is over the air firmware updates. So at a network level, it's possible to have over the air firmware updates when such things are required. Whether we provide an update in general, or as the previous point mentioned, we require to do some remote debugging, everything's done over the air, which is the most smooth and seamless way we feel of doing it, and certainly the most advanced way of doing the support. And then lastly, we feel that it's a mandatory requirement for a modern, complex, software-defined system that it has these 4 elements. As I said before, the bug fixing and robustness of the system is very important. Achieving a true interoperable system, whether it's with emergency, as the topic is today, or whether it's beyond emergency to lighting controls. We think that we've achieved an exemplary level of interoperability in the market and in those projects, those many projects that we've done up until now. And then security being of a high importance, and we continue to support the best security solutions as we possibly can, and then responding to the market needs by regular introduction of new functionality, and obviously the new solution that we're all delighted to be involved with today with Tridonic is the wireless emergency solution. So in closing, I'd like to thank Tridonic for their support in the development, and also hope that those that have joined the webinar today will find it informative and interesting, and we hope to get some questions after the session here. Thank you.
Thank you very much, Stephen, for that very nice presentation. Also for you, please don't run away, stay online, because just in a few minutes we have the final Q&A session of that. As just heard, the planning and the legal requirements are very important, but at least as important is the right luminaire design. So that's what we're going to talk next, is luminaire design in, and for that we have our application engineer, Harald Müller. So Harald, the stage is yours.
Hello, my name is Harald Müller, and I'm going to give you an overview about how to design in radio components in a luminaire. Wired and wireless connections differ very much. Wired connections are static and do not change, compared to wireless connections, which are dynamic. By changing the external circumstances, they can change or be disturbed. Basics of electromagnetic waves. Examples of electromagnetic waves can be found in technology and everyday life. This means we have radio waves, microwaves, thermal radiation, also light, X-rays, and so on. The only difference between this is the frequency in general. The relationship between the speed of light, frequency, and the wavelength is shown in this formula. The wavelength especially is interesting for our purposes because the wavelength defines the cutout we have to cut in a metal luminaire. Radio waves propagate spherically. This means the signal strength decreases quadratically with the distance. Different frequency bands are subject to regional restrictions. The only frequency which is worldwide freely available is the 2.4 GHz band, where also basic in wireless with the Bluetooth is located in. Now, used for a variety of different applications are WLAN, Bluetooth, Thread, or ZigBee. By using the same frequency band, these applications can influence each other. Therefore, please note, WLAN can influence other applications, especially when the load of the WLAN is high. An analysis of the occupancy in the frequency band before installation of a longer time is necessary in order to make the right channel decision. Occupancy in the frequency band is dynamic and can change at any given time. Now to the factors influencing radio waves. Factors influencing radio waves are things like reflection, interferences, diffraction, shadowing, and also damping. In this graphic, all these various influencing factors are visible in a free air condition. I used the free air because in free air these factors do not overlap. First influence is the reflection. Radio waves that hit a metal surface are reflected by this metal surface. Result of this are advantages and also disadvantages. One advantage is in rooms, reflections are often advantageous because they allow every corner in a room to be reached. Disadvantage is interferences. If different radio waves overlap, this is called an interference. Radio waves arrive at the receiver in two forms. One is direct and the second one is reflected. This leads to a sum of the reflected and the direct radio waves. In some cases, this can cause a doubling of the signal strength, but it can also lead to a cancellation of the signal. Now to diffraction and shadowing. When radio waves hit an obstacle, the radio waves are diffracted. Diffraction depends on the following factors: the frequency of the radio wave and the size of the obstacle or the passage between this obstacle. Diffraction has both positive and negative effects on the propagation of radio waves. Positive is, with diffraction, radio waves can reach areas that don't have a line of sight between sound and receiver. Negative is that there are areas behind the obstacle in which shadowing occurs and where you cannot receive a signal. Here is an example on the left side. Obstacle with a narrow passage means that the angle behind the obstacle is higher than as compared with the middle picture where the passage is wider and therefore the angle is lower. This means if you have a wider passage, you have a bigger shadowed area. In the third picture, you see behind the obstacle that there is a completely shadowed area. Also in this area, you cannot receive a signal. So last but not least, damping is also a big influencing factor. Dependent on the metal, we have higher or lower influences. Wood and plasterboard and also bricks are weak damping or medium damping materials compared to reinforced concrete and metal, which leads to a strong damping and very strong damping. Therefore, please note, metal does not allow radio waves to pass through or only with great difficulty. If you surround a basic dim wireless module with metal, you create a Faraday cage where radio waves cannot escape. The weakening effect of metals is not obvious. Pay attention to tinted windows as an example. Now to the range of radio waves. We have some influencing factors which can reduce the range of radio waves dramatically. Influences on this are the antenna itself, also the transmission power of the radio module, the luminaire design, and also the spatial conditions. On the antenna design and also the transmission power, we cannot influence because this is fixed, but we can influence the luminaire design and also the spatial condition where we install the wireless luminaires. On the right-hand side, the graphics show what 10 dB of radio signal quality loss means in reality. Here in this example, 1 megahertz. With 1 megahertz and 10 dB loss, we reduce the range of around 70%. So now to the installation of the radio components in the luminaire. The correct placement of the radio components is essential. The following points can influence the signal quality and must therefore be avoided. Enclosing the radio components with metal leads to a Faraday cage. Insufficient distance between antenna and metal parts, and also shadowing the radio signal by metal parts. The distance between the antenna and the metal parts should be as large as possible. You see a graphic where simulations with metal in the range of the antenna are shown. This means more metal or lower distance to metal reduces the signal strength of the antenna. A distance larger than λ4 is optimal. This means in basic dim wireless applications 30 millimeters and more. On this picture we see an optimum luminaire. This means we have a plastic diffusor and the radio waves can escape the luminaire through this plastic easily. Compared to this luminaire, where we have a metal frame and also a metal LED board mounted on a reinforced concrete ceiling. In the application itself, this luminaire leads to a bad signal quality. Compared to the measurement in the laboratory, where this luminaire is not mounted on the ceiling and radio waves can escape easily. But in the application itself, it leads to a problem if you mount this luminaire on a ceiling. Now to the cutout for metal luminaires. The size of the cutout depends on the used frequency. In this case, it's 62.5 millimeters and a width of 10 millimeters. Please note, untested luminaires can lead to the significant signal quality problems. The combination of radio module and cutouts in the metal frame must be tested for signal quality and range. Each time the cutout or the position of the radio module in the luminaire is changed, the luminaire must be tested again. Last but not least, we also have the influence of the spatial conditions on the luminaire and the signal. The conditions on site are also essential for the trouble-free operation of luminaires. The luminaire that works in the laboratory is not a guarantee for a functioning system on site. Following on-site conditions must be taken also in account. This is the ceiling, materials in the wall, windows and panes, and also other radio system. Many thanks for your attention.
Thank you very much for this detailed look into the design in of a luminaire. So now I welcome for the last and final part of that session, the guys here on stage. So I welcome here Elias, Manuel and Harald for the Q&A, and as well live we have Stephen and Simon online. So, and Andy, I see you are ready for the questions. So please, I'm handing over to you guys.
Thank you, Klaus.
Thanks, Klaus. Thanks, Klaus.
Welcome back, gents. And we got quite a lot of questions. Going into the direction, I would ask that you, Harry, can you give us a statement or a bit of feedback on what is approximately the maximum distance between Bluetooth devices?
The maximum distance between Bluetooth devices is dependent from the luminaire itself and also from the circumstances where the installation is installed. It's not possible to give a general number of the distance, what's possible and what not.
Okay, and when you say it's depending on the circumstances, do you have some examples for that? What really influences the range or the signal strength of the Bluetooth devices and the Bluetooth signals?
Yeah, the main influencing factor of the Bluetooth signal is metal near the antenna of the Bluetooth device. This means metal shifts the resonance frequency, and therefore you also shift or you influence the quality of the antenna, and therefore you can reduce the signal quality and also the range of the signal.
Okay, perfect. Thanks for that. And I guess as a lot of the luminaires of our customers and our listeners online are made of metal for sure. There was also a question, do you have a recommendation for placing or putting the Bluetooth devices inside the luminaire?
Yeah, the recommendation inside the luminaire, best is place the module outside of the luminaire if this is possible. If this is not possible, the best is if you use a plastic luminaire, and what's also possible, make a cutout in the luminaire and design the Bluetooth module in that the cutout and the Bluetooth module fit together. But always consider, test it afterwards that you can guarantee a good quality.
Okay, thanks, Harry, for that information. One question I would have for Manuel, because there was a question coming in, if it's possible to lock the emergency luminaires in the Bluetooth mesh network.
Yes. So when with lock is meant that you are locking them, that you're not intentionally unpair it. I think that's the question directed to. So yes, this is possible under the setting tab in the basic DIM wireless app, in the 4BT remote app. So you can slide that trigger to the left and then it's locked and you don't unintentionally unpair the luminaire.
Okay, and I would have one more question for Elias. That question goes, is when you have a standard DALI driver and an emergency DALI driver in the luminaire, do you need then 2 wireless devices in that luminaire, or is 1 wireless device sufficient?
So if you would have a combined emergency luminaire that has on the one hand side a standard LED driver and on the other hand side an emergency driver, you can connect them to a single wireless node, to a single basic DIM wireless device, and they will then pop up in the app as one wireless node. And again, on the SceneCom also, you will see that only one single luminaire will be present. But behind that, there is both the emergency driver and the LED driver.
Okay, and I have one question which I would like to give to Scotland, to Stephen Jackson. Stephen, I hope you can hear me. And that question goes, is it always needed to have a Tridonic SceneCom controller for the emergency handling, or can that be handled directly in the Bluetooth app?
You should be online right now, I think.
Hi, Andreas. Hi. Can you hear me now okay?
Yes,
Yeah,
I think now it's working.
Thank you. Could you maybe repeat the question, please?
No, the question was if for emergency handling there's always a DALI controller needed in the background, always a SceneCom controller needed, or if that is also possible directly in the Bluetooth world.
You need both devices. You need the SceneCom controller, and you also need the gateway device or the DALI controller, the DALI interface between wireless and wired DALI back connected to your DALI controller.
Okay, thanks for that update. And I would like to give one last question to Harry Müller, because there was one question coming in again targeting luminaire design. If there is not a possibility to get the Bluetooth radio signals out, is it possible to connect an external antenna?
At the moment, there is no possibility to connect an external antenna because our devices don't have an antenna plug.
Okay, thanks a lot for the questions. As we still have, as before, a lot of questions in the log, but time is running out. We will follow up then on the questions via the recording. Thanks a lot.
Thank you.
Thank you.
Thank you very much, guys.
Thanks.
Thank you. Thank you, Stephen. Thank you, Simon. So now we have reached the end to the webinar. So thank you very much for all out there for being there, dialing in, listen to us. As I said in the beginning, we will send you the recording so that you can use it. So if you may have not seen the beginning of it, so no worries, you can watch the video afterwards. So I would like again to say thank you very much out there. I would like to give a great thank you for the team here in Dornbirn, and a big thank you to all here standing behind the equipment, doing all the creativity part. Thank you very much and have a good day. See you later. Bye.